Before the age of modern power electronics, one device made our electrified world possible: the transformer. What is a transformer and how does it work? A transformer is an electrical device that uses electromagnetic induction to change the voltage of an alternating current, AC, without changing its frequency. It's important to note that transformers do not work for direct current DC applications. Unlike motors, it has no moving parts. Instead, it relies on two separated coils of copper wire wrapped around a magnetic core. When alternating current flows through one coil, called the primary coil, it creates a changing magnetic field. That magnetic field links to the secondary coil, inducing a voltage. Why AC and not DC? Transformers only work with alternating current because they rely on a constantly changing magnetic flux to induce voltage in the secondary coil. With direct current, the flux would remain steady and no voltage would be induced once the circuit settled. This is why Nikola Tesla's AC system beat Thomas Edison's DC in the famous War of the Currents. AC could be stepped up to extremely high voltages for long-distance transmission, reducing current and minimizing losses, and then step back down again to safe levels for homes and businesses. At the time, DC couldn't do this economically. Types of transformer. Not all transformers are built the same. Each type is carefully designed for a specific role in the journey of electricity. At the top of the chain are power transformers. These are used in transmission networks working at extremely high voltages, often hundreds of kilovolts. Their job is to connect generating stations to the transmission grid, stepping voltage up or down between major tiers of the power system. They're optimized for maximum energy. Next, we come to distribution transformers. Smaller than power transformers, these are the ones you see perched on utility poles or tucked inside street cabinets. Their task is to take medium voltage electricity from the grid, say 11 kilovolts or 33 kilovolts, and step it down to the familiar 230 volts in Europe or 120 volts in the US. Making electricity usable for homes, schools, and factories. Then we have isolation transformers. Unlike step-up or step-down types, these don't change voltage ratios as much as they provide electrical separation. By physically isolating the primary and secondary coils, they prevent noise, interference, and dangerous surges from passing through. Hospitals, laboratories, and audio equipment often rely on them for clean, safe power. Finally, there are auto transformers.